inverse function. So one-to-one is leading us up to inverse functions, which I've been sort of talking about. So inverse functions are very important. It's important to sort of understand, especially when we're going to eventually get into logarithms and exponentials, and to understand logarithms, really, understand them, is you have to understand that it's the inverse of the exponential. Its sole purpose in life is to do that. And so in order to understand logarithms, you have to understand what it means to be an inverse. The same thing as if you do trigs, understand trig inverses, you really have to understand what an inverse is. Not that we do trigs in this class, but if you do go on and take trig, that's what's kind of a very key concept, is inverses. And so what an inverse function is if I have two functions, f and g, they're inverse functions if whatever the function f does, the function g undoes. Right? And that's what it is. Inverses means one function does the exact opposite in the opposite order of the other function. So it completely undoes the other function. Right? So the process is basically, we start with a one-to-one function. Inverses exist with one-to-one functions, or we limit its domain and force it to be a one-to-one function, like we did with the where it's a piece of it where it's increasing, or the piece of it where it's decreasing. All right, so it's a one-to-one either over its domain, over an interval. We can only find inverses if they're one-to-one. All right, so what we're going to do is we're going to create a new rule. We're going to call it g of x for now, but we do have an inverse symbol, which we'll get to in a second. So we're going to create a new rule, f of x, that undoes what the original function f did. This is the new rule g that has the property, it's the exact opposite in the opposite order of whatever the original function was. And so what's important about the property is that sort of to check that you found the right thing is g of x, all right, will have the property if ab is on my function f of x. All right, so when I plug a in, I get b out. The inverse will have the exact opposite point. If I have b then, not if, so if the original function had the point ab, or if I plug a in, I get b out, its inverse should have the exact opposite point, meaning it'll have the point ba, where b and y are interchanged. And so g will be a function where when I plug b in, I get a out, the exact opposite of the f function. Alright, so we know g is a function since f is 1-to-1. And so what we do is we give this new notation. So g of x is the inverse. And so what we're going to do is, we're going to say the inverse is f inverse. So this function notation doesn't mean the negative exponent. It doesn't mean 1 over f. It means inverse. So this means inverse. So just make sure you're careful with that. It doesn't mean 1 over f of x. It means it's the inverse of f of x, the opposite of what f of x is. And so a simple example of that would be the following, which sort of should be, obviously is probably the wrong word to use, but it should make sense that g is the inverse of f. All right, so f of x is the function 8x. Right? 8 times x will give me out my function values. And so my y values that come out are 8. So 1 gives me 8, 2 gives me 16, 3 gives me 24, and 4 gives me 32. And so when we find f of 1, I get 8, or I have the point 1, 8. Well, the inverse should give me the exact opposite of that. Right? And so my inverse would be the exact opposite of multiplying by 8. It would be dividing by 8, and so that's what this is giving me. This is my inverse. Right? And so what you'll notice here is the x and y values are flipped, right? So this is the inverse function, which is represented by the g of x here. It should give me the exact opposite. When I plug 1 in, or not 1 in, when I plug 8 in to g of x, I should get 1 out, and I do. It gives me out the point 81, and that's true for every single one of these points. The inverse means I've undone. I get the exact opposite. My x and y's are all flipped. Right? What was AB here becomes BA here. All my x and y's are interchanged. And so the function g performs as an inverse of the operation s. So g, which is a x over a, is the inverse of f. And to see that that's sort of the case is we'll find the composition, and what you'll notice is they should undo one another. And so we'll do the first one, f of g of x. And so f of g of x, so x over 8. And so remember what f was, x times 8. And so I get 8 times x over 8. The 8 is reduced and leave me with x. And so they do undo one another. They leave me with what I plugged in. Right? If I plug in f of g of 2, I should get 2 out, and I do. You plug in f of g of 2, well, f of g of 2, well, g of 2 would give me, let's see here, give me x over 2, or x over 8, which would be 1/4, which would give me 8 times 1/4, which is 2. Alright, well, what about the other direction? Does it work in the other way? So g of f of x. Alright, well, g of f of x would be 8 times x, plug it in, so I get 8 times x divided by 8, the 8's cancel again and leave me with that. And so that's what it means by it undoes one another. They undo one another if they're inverses. One function undoes the other function. Right? And so my x and y values switch. If I take the composition of them, it leaves me with just the x value. Alright, so that's what an inverse is. That's the goal of an inverse. Alright, so we'll stop there and look at properties of inverses in the next example.